decreased by 40 times in the past 10 years, and the processing cost also has been reduced by 60x. So this is the perfect time. It's a perfect combination to tackle this huge amount of data, how to process that data. So all these things are complementing each other to prepare for this revolutionary Industry 4.0. And another thing is, I just spoke about the big data generation examples. Just give you some more examples. For example, an A380 engine generates 1 petabyte of data on a flight from London to Singapore. Huge data. Safety sensors in mining operation can generate up to 2.4 terabytes of data every minute. And a smart home is able to generate 1 gigabyte of information every week. According to GE, a simple machine in a smart factory is able to generate 13 billion samples every day. So this is just one machine they are estimating they would be able to generate. Imagine a smart factory, a regular size smart factory should be able to generate how big amount of data. So that's what we are talking about. Big data is about information that is coming from sensors or equipment or those things, and all this challenge is basically how to interpret that data, how to process that huge amount of data to get meaningful decisions, to get the decisions that can help to expedite the business, to fine-tune the business for future predictions. AI IoT is at the core of our changing world. There are 200% growth of information-based product and services by 2021. This now, 73 zettabyte of data in 2025 generated by 5. I just explained that earlier, and 62% of developers deem IoT very important to digital strategies. So, and more than 55% of all data forecast to be generated by IoT in 2025. Around half of that data will be created and processed outside the data center or cloud by 2022, which is next year. And 43% of share of AI tasks taking place on edge devices this 2023. And the most important thing, the economy, the annual business-to-business IoT revenue by 2021, which is now, is around 300 billion. And it's going to increase in the coming years. It's going to exponentially grow. It will be there on this side. So these are the indicators. These are things that this is the right moment. This is the thing that we need to jump into this wagon, this ship as early as possible and get ourselves prepared for this revolution that is coming in, unfolding very in front of us. And IoT to transformation. So if you can just want to give an example, transformation, the way we live and work, saving lives, from improving quality of life, growing yield, enhancing public safety, optimizing productivity, driving efficiency, protecting the planet means global warming. Here, I would like to share a video for just for the sake of more info. Here is. Just give me a while. I want to share video. This video basically shows, it's a little bit old video, but whatever the contents are relevant today, this shows how IT is transforming our world. Okay. All right, we are back. So, as you have seen, how our life is going to transform using this IoT, big data. And by the way, the data itself is being considered as a new oil. This is the oil for the industry. So data is everything moving forward. Data generated from ourselves, from sensor, from machine, from every aspect of life. The data will be very important, and that's where Facebook, Google, all they actually they need our data, they need our patterns, everything to make intelligent decisions about and sell to industry. Now, there's another important aspect for this whole thing is the edge, the placement of computer closer to the data source or point of service delivery. In the earlier files I mentioned, huge amount of data will be generated from these Internet of Things, of in devices in the factory, home, those things. If we and the cloud is basically on our right hand side where the processing is done. This was the traditional view of looking at IoT. But moving forward, more and more this compute is being moved towards the edge near to the devices. Why? Because the huge amount of data that's going to be coming from these devices, if we send them towards the cloud, it's going to consume a lot of bandwidth, a lot of these latency issues, bandwidth, security issues, those things. So the trend is to bring these compute power as near as possible to these devices so that the processing is done, and then only the meaningful information are extracted from that data and send those limited data or meaningful data to the cloud for high level processing. And for example, this factory, there's a compute, there should be a compute on premises, a core server or Xeon processor that takes all the zettabyte of data, or the terabytes of data, do the processing, and at the end extract some meaningful information, send it to the cloud. And on the cloud, the business logic will use that data along with the supply chain management, all those things to make efficient decisions. So basically, when you might be hearing in coming days about is edge. Basically, edge means the putting compute power as near as possible to the sensors, to the entities who are generating the data. From Intel, we have these are the technology that we offer, that real-time manageability, functional safety, computer vision related products, security. Oh yeah, security is the top most priority for, and not only for Intel, I think for all this industry, for Industry 4.0, security is the very important stuff. We don't want external forces to jeopardize the processing or operations, and that's where this is one of the utmost thing. Then the virtualization is basically using the same compute power to do different things in an isolated way. Hardwares that Intel offers is Atom for the edge, Core and Xeon for the compute, and for both for the cloud and for the edge as well. For the inference means applying the AI on our already built models to get the results. So we have offer Movidius, Starpratics, Arira. These are some of the chips or hardware that Intel offers for these things. And Wi-Fi and Ethernet, we also have our Wi-Fi Ethernet cards in hardware to support the connectivity. Next is again, AI is changing every market. Similar thing, cities, energies. Just now, I wouldn't go into this detail. Then the next is the final. I think my time is also going to be over. Top trends of AI big data in 2021. Again, this is just my own kind of, there will be more to that, which my fellow panelists will talk about, but this just how I see this pandemic, post-pandemic. I think now, since everybody is working from home and all those things, remote working is has catched up a lot. This actually pushed towards more optimized connectivity, those things. So 5G will be even move faster. COVID-19 has pushed 5G forward faster. Meantime, since 5G is from the edge to the cloud, the on-premises networking is still to be used, Wi-Fi, and that's where the Wi-Fi 6 still coming soon. Wi-Fi 6 was promised to give a better, more improved speed, but with more device connectivity support. Um, Post-pandemic, continue heavy focus on the analytics. That trend will continue to be there. AI and machine learning powering business through the pandemic. And then another one of the important thing is the blockchain. Uh, Blockchain technology is the backbone for Bitcoin or those things, but blockchain is just a generic technology to save to organize the data, to secure the data. So that temper free and all those kind of things are met. So I do see that the blockchain kind of technology will be used for big data analysis or to secure the big data. So these are the few trends that will continue to be, that will accelerate in a post-pandemic kind of environment. And yeah, and towards the end, I just want to give an kind of maybe if you guys have not aware, artificial intelligence. Basically, artificial intelligence is a very high level term, is a big term, is umbrella that has the machine learning inside a subdomain, and inside the subdomain is the deep learning, and a lot of research, a lot of interest has been in the deep learning. So when they talk about deep learning, it just means they are talking about machine learning and artificial intelligence at the same time. Just to give this, just to give the context. And the last point is this: machine learning is not everything. Nonetheless, it is definitely something that will change our future. So yes, that's I think that's all I have. Thank you very much. Back to you, Sharon.
Oh, wow, that's amazing. Thank you so much, Mr. Arshad, for your wonderful insight for all of us today. It's truly amazing, something that, I've never seen as well. All right, so we will move on to our next presenter. I would like to invite Mr. Usman Sarwar to share his vast knowledge on our topic today. Please, Mr. Usman.
Okay, are you able to hear me?
Yes, very clearly.
That's great. Thank you very much for having me in this webinar. Thanks to you, Sharon, and thanks to the team, a good team from your university. So before I go further, could you please confirm that you are able to see my screen?
Yes.
And okay, is it fully viewable?
Yes, it's widescreen.
Okay. Today we're going to talk about pilot smart city design and development of our smart city 4.0. And the primary reason is because for the past 1.5 years, I have been involved as a solution architect and a project manager for a Monash smart city project in Australia. It's the Monash is a city which is near to Melbourne. And prior working for Monash University, I was also part of the Intel IoT group. And thanks to Arshad for explaining some aspect of big data as well as the smart city in the video, which actually explains a lot of stuff which I want to also convey in this presentation. Anyways, before I go further, basically this project is a Australian government project, which is And for the slides, consistencies and what about my current role and previous roles. The first important thing is to understand what is sparsity, because as you know that everybody got their own definitions. You can, when you can find definitions coming up from different countries and so on and so forth. What ISO, which is the International Standard Organization, and I think most of us must have heard about ISO, as they've been providing standards in different areas, from technology to non-technology based solutions. I have to go and I have to basically just read this because this is important, and then we will discuss about overall city aspect of it. So a city that increases the pace at which it provides social, economic, and environmental sustainability outcomes and responds to challenges and uses data information and modern technology to deliver better services and quality of life to those in the city. Why I read this one, because what we are going to discuss in this presentation is what we have done based on this definition for Monash Smart City project. And just to give a context about the data which is being generated and being used for data-driven decisions in the cities, you can see on the right side of my slide that there is a average 25 GB used by the internet users. Smart card uses 50 GB per day. If we talk about the hospitals, they're going to generate 3 terabyte data per day. We talk about planes. It's a tremendous amount of data, which is 40 terabyte, and factories are generating petabytes of data per day. Now, just imagine the cities are having different buildings. They have hospitals, cars, and all type of civil infrastructure. Just imagine how much data they will be generating. Just imagine about Kuala Lumpur itself in the future. So we're gonna deal with the tremendous amount of data coming into to handle and crunch and take out those patterns. So it is a very exciting. It's a very exciting area to work in, especially for me for the past 1.5 years in this area. And one key aspect which I want to mention here is there's an ISO standard with an ISO number 37122, which was standardized in 2019. This is a very good standard to refer to because it actually provides us how to use indicators. For example, whenever you're gonna work on any technicality and making a solution coming out of it, you need to have some way of confining it, and indicators are a very good way of measuring your tangible output coming out from, for example, parking data, waste management data, and so on and so forth. Now I'm going to jump into the next slide to give an idea about where is Monash. If you look at this map, you can see that this part is in Melbourne, and this is the whole area which is the Monash city. And within the Monash city, there is an area called Auckland. Monash city itself is a 81.5 kilometer square area, and within the Monash, there is a Auckland town where we have piloted this project. So as you know, most of the time when unproven technology is going to be deployed, and especially the city councils as well as the technical companies or technology companies, they don't have actual background of deploying. So the way that we do it is to confine an area and where we can deploy and test the technology. So the smart city project is basically deployed in the city of Monash, and specifically in the Auckland area. And the key purpose was to create a digital and civil infrastructure for data-driven smart analytical applications. And why do we need it? Because in the end, it's all about business. It's all about providing services to the residents and to the business owners. And one of the key aspects there is that how are we going to make data-driven decisions for one side is the city council because they are operating the different type of services for the residents, and other side is the residents who are going to use it. So that was the baseline for us. And if you search for iSense Oakley, you will find out the actual project details as well. Okay. So what are the key objects and deliverables? The first one is to create a connected sensing arrays, which means we basically deploy different type of use cases, including street lights, parking, panes, and so on and so forth. And the reason is to basically integrate with the civil infrastructure and get the actual data, 24/7, and which can give us a very good insight about how the civil infrastructure is being really used. Second one is to look at how we can utilize better our resources, especially to reduce congestion. In this case, we have parking sensors, we have different type of, smart cameras, LiDAR that we've been using. I will give some background later. Furthermore, we also want to save energy, and one of the things which we have deployed is smart street lights, which are adjustable according to the ambient lights of the area, as well as it looks at how people are moving in that area, so it will readjust itself and also increase the safety. The safety aspect is very interesting. If you look at some of the articles, you will find out that generally speaking, the psychology of people, if there is a place which is under the light, people tend not to do anything harmful. And so the street lights or smart street lights we're providing, one aspect is to reduce the energy consumption, because when we talk about, the street lights, let's take Kuala Lumpur. Kuala Lumpur has thousands of street lights. So that's a very expensive infrastructure to use electricity. And secondly, if there's a way that we can provide, sub-use cases, so the smart light was providing the safety aspect as well. And lastly is to improve services and, somehow sustain it for a better future. This is to give a very high level architecture for the Mona Smart City project, where, as you can see on the bottom, we have the first tier is the IoT edge devices. We have basically parking sensors. We have smart cameras. We have basically LiDAR. We are using PITs. There are tons of different types of sensors, which I will explain in my next slide. Then we have a network infrastructure consisting of different gateways and computing devices. The IoT devices are connected to the gateway using ZigBee, or partially ZigBee, I could say, because it's using sub-gigahertz 802.15.4 radio. We have LoRaWAN, we have Wi-Fi, Bluetooth, and so on and so forth. On the connectivity between the edge to the cloud, we are using fiber, we are using 4G connectivity, and whenever the 5G connectivity will be available, we are ready for it. So primarily, the first important layer is the end-to-end communication infrastructure, which what it really means is from the IoT devices to the backend system, there must be some communication pipe. So as I explained earlier, that these different type of devices are using different connectivity based on their needs. And the edge devices or like gateway devices are being connected with the backend cloud services using fiber and 4G. So that's how we are constructing it. It's actually a quite expensive journey, because you basically have to dig the roads. You have to, have those expensive fiber to put in the road. So it's a lot of labor work and takes a lot of time to actually construct it. In our pilot project, we were using roughly a 1 kilometer square area. So just imagine that we basically spent $100,000 only to do this communication infrastructure part of it. The second part is the data engineering and integration framework, which is running on a AWS cloud. We have developed this framework based on specifically city council requirements. And then we basically did the infrastructure use cases on top of the data engineering and integration framework. And these use cases included parking, bin, pits, and so on and so forth. What it means is that when you basically push the data or you pull the data from the IoT devices to the backend system, just try to visualize that all of them, they will have their own payload formats. They will have their own payload sizes. So you basically have to do a certain type of, applications and, microservices to basically get those data and put it into your data lake, and then, do something with your machine learning models to create a value for the customer, which is a city council residents. So we did a couple of stuff there. As an example, getting tons of data coming out of parking sensors for the last 2 years. We able to do short-term parking prediction, and similarly, we did a couple of other stuff there. This is the holistic view of the use cases and high-level integration architecture. I will start from the top left. We have basically smart lighting, and the key thing here is to basically manage them remotely and also provide different services, such as we have position sensors also attached on these smart poles. And the difference between the normal pole and the smart pole is the normal pole only has a circuit to basically get the electricity to turn on and off light. In this case, it has two separate circuits. One is for lights. Another one is to use the devices like 4G or Wi-Fi or smart cameras, which are connected through the fiber optics. Then we have we'll talk about the smart parking. We have around 700 parking bays connected to the LoRaWAN infrastructure, to the LoRaWAN gateway. We have infrastructure of bins, which are primarily monitoring the fitness level as well as temperature if there is a fire in the bins, because sometimes people do throw the secret buds which could cause and which has caused in the past come from fire. So then we are monitoring the pits. Pits are basically under the road. It's a very complicated infrastructure, the civil infrastructure, where you have different severages and so on and so forth. So we also monitoring those aspects in order to provide a better operational decisions for the city council. And on the top, we have a traffic and pedestrian monitoring. These are basically LiDAR. We are using expensive LiDAR to monitor in 200-meter range one of the intersections to know about the how people are moving around, as well as providing them privacy-based solution. So using LiDAR, you don't capture anyone's pictures. So, and we also can understand about the traffic flow and so on and so forth. This data engineering and integration framework is the one which basically collects all the data, and there are several applications and services which are running. And in the end, it provides dashboards. It provides access to the residents using mobile apps and so on and so forth. So this is to provide some understanding about what we are doing with the data, because as you know, that the key aspect of putting all those sensors, network infrastructure, and building the data engineering integration framework on top of the AWS, it's actually a very expensive journey. We have spent hundreds of thousands of dollars to actually build it, and the key thing was to get the data. Just like the way Arshad also mentioned that data is the next oil. So we basically start getting that idea about what we can do with the data. And I mean, coming out from the software background, we can actually look at these data from a software perspective, but this type of data is very useful for the planners, like city planners and the team which are managing these cities. So as an example, for the smart parking, you can see that this graph actually shows the average occupancy throughout the week. And this is during the time when Melbourne was under lockdown. Similarly, the third one shows during the daytime, around 92.8% is all vacant and 7.2% is occupied from 700 parking bays. And this 7.2% is basically reflected here on the areas, different areas within the monarch which are having parking monitored. And lastly, on the parking side, we can see this is I choose this graph on purpose because I can actually show you how COVID-19 really impacted the area, especially for the parking. As an example, this is monthly data showing 87.5% occupancy in the month of January to 2020. And by February, when COVID-19 was start hitting, it actually dropped to 67%. Then around March time to April, it was lockdown and partial lockdown, so it goes from 67 to 72 and 70%. Until June, when government controlled the situation and they actually open up for public to use. And it actually spiked all the way to 94%. By July and August, we get a lot more cases. You may have also seen from the news. And afterward, we again dropped back to lower than the 60%. Similarly, on the smart bin side, we're actually doing, collecting the data about the fitness level and also looking at the temperature. So this is the live data coming out from there. Again, we can get the idea about what's going on for the last 7 days. And when the contractors are going and unfilling the bins, pits is something similar like bin, but it is under the road. And we basically know in a live data scenario that how it is actually fluctuating up and down with the triggering of the factors like rain or some type of floods. So we could actually get some type of insight in understanding about how to manage those pits. And lastly, I just gave you one of the pictures from the smart lights, but there are other aspects of analytical journey that we have come across with the smart lighting. I'm not able to show all the data, but I'm able to show some idea. Some data which can give you an idea about how can a data-driven future cities will look like. And this is also a very interesting thing that we have done, which is a pedestrian pattern monitoring and analytics. What it does is we have actually put special type of devices on smart poles. All of these green anchor points are basically the poles. We have those sensors, and what it shows throughout the day is the patterns of people there. And we basically collect data using Bluetooth-based devices. So I just give an idea about how it looks like from the Bluetooth point of view. But for the actual context, we can see throughout the day how many people actually move and how it actually changes. And why do city council really need it? Because they can plan their parking, they can plan their, the waste bins according to the flow of pedestrians there. And furthermore, they also get idea about which commercial area is more successful for the business owners. So the key conclusion which I can say here is that, it's a very challenging journey for me for the last 1.5 years because there were so many things that we have to cope up with. There are from devices, network infrastructure to make applications, and also finding people and managing different type of stakeholders in order to make it. So I mentioned about a couple of challenges here, which is there is a segregation and integration problem of heterogeneous technology. What it means is, like when we buy a couple of bin sensors, using LoRaWAN as an example, we found out that there is also a silo ecosystem there. So let's say when we buy the bin from one vendor, they actually close it into their own silo of all devices and backend systems. So we actually have to work on the data sheet and understand about how we can extract the data and then do the encoding and decoding on the backend cloud systems. Similarly, we found out problems with non-standardized way of payloads. So just imagine if we have several parking sensors, we have tons of bin sensors and pit sensors. All of them were having their own formats. So we actually have to create decoders, which can decode the data according to those different devices. So what it tells is that there's a big problem with the standardization of payloads and payload formats. So if people really follow the formats defined by the standard, it makes integration more easier. Then there's a problem also with the data interoperability again, because in some cases they use different units, in other cases they use different type of unit from the hardware itself. So once you start working also on this, these type of use cases, you will also found that there are a lot of integration-related challenges. Second one is smart city main stakeholders are basically the residents or the taxpayers. Secondly, they are city council people, which need to provide actual requirements of their challenges. And I specifically mentioned it is not an IT push solution, because when I worked previously in IT companies or tech companies like Intel or before Intel, we basically have our perspective coming out from, okay, we should push forward these things. This is very natural for engineers. But in reality, the actual users are the city council people and residents. We actually have to build the technology which fulfill their needs. And this is what we actually learned in this project, because many vendors, they were simply buying solution from Korea, Japan, US, and they just try to put the same solution in different cities, and then they claim, okay, we already finished the smart city, but it didn't really solve the problem of the city council people. So in this case, we sat with the actual operational teams. I basically chased the trash collector truck, try to understand about their problems. How do they basically collect the trash? What are the challenges there? Similarly with the people which manage them. So those requirements were used to build this solution. And lastly, designing, developing smart cities closely with the operational city council team is a good way, which I already explained to you. Why? Because once you solve the actual problem, they are going to use your solution, and they're going to basically pay for it. So thank you very much for listening and getting the idea about what we have done from the last smart city project. You can reach to me by my email address, LinkedIn, and Twitter account. Thank you very much.
Oh wow, this is another incredible knowledge, especially on smart city. This is something that we Malaysians, we would like to hear a lot more. Thank you so much, Mr. Osman Sarwar, for your knowledge sharing with us. All right, for the participant, just a reminder, please ask your questions in the Q&A on the right-hand side at the bottom if you want to ask any questions to our presenters. Or you can raise your hands by clicking on the button on the right-hand side bottom, and the host will allow you to ask verbally during the question and answer session at the end of these presentations. Now, finally, I would like to warmly invite Mr. Peter Kwa to share his knowledge from his digital background. Please, Mr. Peter Kwa.
Thank you, Sharon. Thank you. So good morning, everyone. And my name is Peter, and I'm not sure if I stayed in data science team in Red Media Group, formerly known as Digital. So I'm going to talk about big data analytics in the fourth industrial revolution and give all of you a blueprint or a framework for it. Okay? Now, before we go to the details, first of all, we really need to understand what big data analytics or BDA is. I mean, it is simply the analysis of data that is true. Okay? Like what Arshad has mentioned. And what is big data? We can think of big data in terms of the three V's, Number one, volume, growing volume. For example, 90% of the world's data, was generated in the last 2 years alone. And number two is growing velocity, the speed of data being generated, the velocity of data hitting us every second, every minute. For example, Twitter, generates about 500,000 bits per minute. And lastly, velocity. Now, I think most of us, can pretty much understand volume and velocity very well, but what is variety? So 80% of the world's data is unstructured. Now, what is structured and what is unstructured data? So structured data, is data that you typically find in your databases and that you can perform queries like the SQL, like that. Now, what about unstructured data now? Unstructured data, right, is really data that we cannot immediately analyze without pre-processing it, okay? So we're talking about emails, logouts, videos from CCTV, images, text from social media, and even your business report, okay? Now, why is unstructured data so important? Because you will be missing out on a lot of valuable business cases or use cases if you don't start analyzing this kind of this unstructured data. Okay. Now, if you look at this slide, right, 5 years ago, right, when I was in NDEC produced the National Big Data Analytics Framework, the results were actually very disappointing. Okay. The entire country, and we're talking about Malaysia here, right? The entire country was actually labeled as a starter or level 1 or even an infancy level. There was no strategy for big data, there was no budget for big data, and most of the big data projects were very ad hoc and experimental. Now, fast forward to 2019, in 5 years, right, we managed to actually leap from level 1 to level 3 or systematic. And what is systematic? So systematic is where we are now deploying machine learning for common business cases. There is a recurring budget for business. Companies are also very actively hiring data scientists. And in terms of data governance, we are actually getting pretty good in securing, our sensitive data. Now, what about 2020? Okay, so last year when we did the survey, and we found that the needle has definitely moved. We are still at level 3, but we have actually moved to a more mature level 3 compared to 2019. Okay, so in 2020, right, the industries with the highest PDA and also AI maturity, that would be our telco, media, aviation, and also financial services. Now, is this really a fight? Not really, because they are highly mature because they have been forced to adapt or die to that. Okay. This is one example. Competitions in telcos and airlines are so intense that any advantage they can get from BDA and also AI can make a difference in their bottom line. Okay. Same for media, the print and traditional advertising, they have actually pretty much gone down the drain. Okay. Facebook and Google in Malaysia have grabbed at least 70% of the digital ad market share in Malaysia. Okay. Media companies are actually forced to think of new business models, taking advantage of big data, also AI, and fight back, against Facebook and Google. Of course, financial services, with fintech threatening them and with market share margins falling, traditional banks, have been forced to adapt and even work with fintech. They have actually invested billions and billions of ringgit into digital transformation and, to be exact, data-driven digital transformation. Okay? So a key finding from the latest survey was, in Malaysia, right, descriptive analytics still dominate our analytics. So what is descriptive analytics? So many of you have seen this famous Gartner image that actually shows 4 kinds of analytics that we can do, right? And you will know that descriptive analytics is the simplest form of analytics. It actually provides information into what happened based on historical data that your company has. For example, how much coffee did we sell last quarter? How many postpaid customers actually left our mobile network last month? What were the oil losses suffered by the palm oil factory today? So again, right, even though the simplest kind of analytics, don't be fooled by it, because if you can ask the right question many times, the simplest form of analytics, in this case, descriptive analytics, right, can give you the insights and the answers that you need to take the right action. There's more to this in the next couple of slides. So I'm going to give you an example of descriptive analytics in action. Many of you know that Harian Metro, right, is our country's top newspaper, right, and also our top web portal with over 100 million page views every single month. Okay? Now, before creating this dashboard, we actually asked ourselves, what were the reading patterns of our new users throughout the week? And we define our new users as people who actually visit the site only once in the last 30 days. Okay? And what did we find out? These new users were very active at certain times of the week. To be specific, right, between 11 a.m. to 1 p.m. on Thursdays, and between 3 to 9 p.m. on Thursdays, okay, and between 11 a.m., 1 p.m. on Fridays as well. So now, right, we actually have the insights that would allow us to take action. So for example, right, at these days and time, we could actually release a lot more relevant content that would engage these new users and try to convert them into what? Loyal users, of course, okay? We could also try to segment the demographics and behaviors of these new users and run highly targeted advertisements to them. Now, why do we want to convert new users into loyal users, right? So that's probably one of the questions you ask. So in this slide, we define loyal users as users who actually visit the site 15 times a month in the last 30 days. Okay, and why our obsession with loyal users? Now, if you look at this slide, right, it is actually our advertising revenue. We see that our loyal users actually give us the most advertising revenue. You know, even though, now here's an interesting part, right? Even though loyal users only make up 20% of our total users. Okay, so the opportunity, right, to convert our new users to loyal users and to increase our revenue, our ad revenue is so huge that we make this decision, right, thanks to simple descriptive analytics shown in the last slide. Okay, now, so the insights. So one lesson learned is the insights and the result that you receive from analytics, right, must allow you to take it to increase revenue, to decrease cost, to increase efficiency. You know, otherwise, what is the point of doing analytics? Okay, so lesson is don't shock and really lah. Okay, so next time when someone asks you, you know, to create a report for them, ask them what actions will they take based on the insight that you will give them. You know, so this will at least we can at least get them to think about it, and will also prevent you from generating a lot of useless analysis. Okay. Now, what about AI maturity? You know, so right now, last year, you know, we are still at level 2. So basically, the needle hasn't moved at all. Basically, in Malaysia, right, AI has become mainstream. You know, companies are deploying machine learning in the form of statistical learning. But however, a lot of analytics is being done with structured data. Okay, companies are also beginning to create AI-driven products. Okay, unfortunately, none of the companies we surveyed has become level 3 or, you know, what we call the Yoda the grandmaster yet. We have not really mastered deep learning. You know, a lot of industries have not really mastered analytics with unstructured data. You know, and we have not really seen a lot of AI-driven products, like, embedded into the industry's business. Okay? And if you look at the AI maturity by industries, right, you will see again, telco and media, right, are actually quite far ahead compared to other industries. Yeah, and we are actually on the verge of becoming the AI grandmaster or level 3. And again, the reasons are actually pretty obvious, right? Competition and the need to survive has actually forced these two industries to adapt and find new ways to exploit disruptive technologies such as big data analytics. On the other hand, if you look at the other extreme, we have the construction, retail, consumer goods, and even agriculture, right? These are what we call the AI laggards. Okay? These are your traditional businesses set up by our parents or even our grandparents, right? So changing their mindset and culture, you know, is going to be a bit more difficult. But thanks to COVID and MCO, you know, many of these businesses are waking up to digital transformation, and we hope to see these laggards catching up in their data-driven initiatives in the next 5 to 10 years, right? You know, right? Sometimes, you know, parents and grandparents, right? They just have to give their sons and daughters, you know, the millennials and also the Gen Z, right, chance to transform their traditional okay. So here's an example of how you know, customer analytics based, you know, industries with a lot of customers and customer analytics, you know, make use of AI to generate more revenue. Remember, right? Analytics must be actionable to make money for you. So we actively do a lot of in Red Media Group or Media Group, right? We actively do a lot of look-alike audience targeting. You know? If you go to any of our websites, you know, Harian Metro, SAYS, Obula, NSD, Berita Harian, right? You will notice that we don't require you to register. So this means that we don't collect information about you. You know, like your like your age, your gender, your race, your name, household income, but these are valuable information for advertisers, obviously, right? So how do we get this data? Well, sometimes we will do surveys, and our readers will fill in the survey for a chance to win something. So of course, not everyone will fill the survey, right? So maybe only about 5% of our readers will fill in the survey. So this would be what we call our seed audience, right? So we will take the information from this 5% seed audience, you know. So for example, we have to fill in their household income data, right? We use some machine learning matching algorithm, and forecast the household income for the other 95% of the population. And we sell this combination of first-party data and also the probabilistic data model to our advertisers. So in case you're wondering, right, popular ad platforms like Facebook and Google, they all do the same. Okay. So another key finding is, organizations are not adopting self-service now. Malaysian management still expects all of us to cut and paste reports into PowerPoints and email them. Okay, instead of them logging in and viewing the report for themselves. Okay, so this is actually a big problem because you will fail to obtain real-time visibility, of your organization, which will actually delay your decision making. So let me give you one example, right? So in Media Prima, right, we have a dashboard that actually tells us in real time how engaging our articles really are. Okay? So imagine if you as a stakeholder, right, only choose to receive this report only once a day. You'll be actually losing out on a lot of potential revenue. How will we be losing our potential revenue? So for example, right, this dashboard here is telling us that this specific article, is currently acquiring a lot of new users in real time. Okay? And if you make it a habit to check the dashboard a few times a day, you will know how to take advantage of the insights provided and optimize the new user experience. For example, right, you can very quickly get your editors to write more similar and relevant content and push them out to engage these new users, potentially turning them into loyal users, making more money. Okay, as shown in the previous slide. So yeah, what are you waiting for, right? Again, if you are not taking advantage of self-service analysis, you are just losing out on opportunities to get real-time insights to make fast and accurate decisions for your company. Okay, so what are the biggest obstacles to achieving high analytics and also beyond? Okay, number one, talent. Lack of expertise in advanced analytics like artificial intelligence. Some companies that we surveyed are also asking for data science professionals to be accredited because of the hype surrounding AI. Lots of people are claiming to be data scientists, so accreditation could filter out the bad data. Okay? Lack of expertise in advanced data processing. I'm referring to text processing, image processing, video processing. These are all unstructured data that we have spoken about, and you need to know how to ingest and process them before applying analytics on them. Okay, budget, lack of budget for use cases, perceived high cost of big data. So the issue is many people think that big data, doing big data is expensive, but that is only because they did not really do their homework figuring out the ROI. Okay? Also, a proof of concept POC, right? To prove your ROI should not really consult. So that's why this is a wrong concept, not to consult with big data analysis. Okay. Number three is lack of business strategy. Okay, many companies do not really have a data strategy, and when they try to embark on BDA, it is very expensive in the future. There is no direction, there is no clear leadership, and management do not really appreciate the value of data. Worse, they do not really ask the right questions. That is why, right, even the simplest form of analytics like business intelligence will not produce any return on your investment. Okay, so I'm going to just in this one, right, and corresponding to the lack of talent of people, right, we ask the companies what kind of upskilling is really required, right? And which one of these is most in demand? Okay, well, these are the results. Okay, predictive analytics. Many people actually want to learn machine learning. Okay, a lot of people are also asking for PDA and even artificial intelligence strategy training. Okay, big data analytics strategy would include understanding the entire BDA ecosystem, asking the right questions, coming up with high impact business cases, that gives high ROI, how to effectively start and deploy BDA and AI projects, key competencies, and how to hire a team of data science. A lot of companies are also asking for data engineering, upskilling, things like building big data pipelines to ingest data, processing unstructured data, having knowledge in advanced SQL, APIs, data manipulation using cloud platforms like AWS, Google Cloud Computing, and even Azure. Okay, very, very huge training opportunities here. All right. Okay. So another key finding is, at this point, it is actually very easy for companies to differentiate themselves, or rather find their blue ocean. Okay? If they are able to create high-value business cases taking advantage of artificial intelligence. Because from this survey, right, most of the companies say that the number of AI applications in their industry is still actually quite low, and they can really differentiate themselves from their competitors. So this is especially true for industries that are lagging behind, like what I mentioned, construction, retail, consumer goods, and agriculture. Okay, so I'm going to skip this next slide here, and we'll go to the key recommendations because we have that time really. Key recommendations to achieving high big data and AI maturity. Right? Number one, training and education, AI upskilling, reversing brain drain, AI education in schools, starting in schools, strategy, top-down direction and clear vision, being able to merge AI project into your business process, more budget for AI, C-level mandate, strong C-level support, sponsorship for data initiative, support for agile development. If you have to fail quickly, okay, so that winning ideas can be rapidly developed and deployed. Okay? Business cases, right? Being able to match the business strategy with use cases, more actionable insights so that ROI can be seen, more sharing within the same industry. So these recommendations are actually key to bringing our industry to the next level of maturity, as will be seen in the slide. So in 2020, Malaysia was at level 3, which is a very drastic improvement from 7 years ago. So can our industry achieve level 4 in the next 5 years? So when we developed this maturity model, right, we thought that these were the 3 key components required for Malaysia to be at level 4. Okay. Now, deep learning, integration of big data with business processes, C-level buy-in, group budget. Okay? And then when we did the survey, we found that these were exactly what the industries were recommending to move ourselves to a higher maturity. So the industry recommendations, right, are actually very consistent with the requirements of level 4. And I strongly believe that we are actually on our way to achieving level 4 maturity in 5 years or less. Okay, so last slide here. So here I'm going to show you the industries, what the industries are recommending from the previous slide, right? Upskilling, clear strategy, C-level mandate. So these are the key recommendations to achieving a high big data and AI maturity. Okay, now who do we train? Our workers, obviously. Who develops the strategy? Our leaders, right? Now, who gives the top-down mandate to do BDA and AI? Our C-level, obviously. Who creates business cases? Our line of business stakeholders, right? So, who are these guys, right? They are all people, right? They are all humans, right? So the key takeaway from this presentation is, high big data and AI maturity is only possible with humans in the equation. Who will be subjected to continuous upskilling, who will define the strategy, who will give the mandate and develop high value business cases. Okay? Actually, it is only possible with smarter humans. Okay? Because high big data maturity, right, is not only about technology or AI or even machine learning or deep. Okay? We need to start preparing our future generations to work with machines and disruptive markets. Okay, so with that, thank you so much. I'll be glad to answer any questions you have or drop me an email to say hi. Okay, thank you. Back to you, Sharon.
Thank you so much, Mr. Peter. Now, that was really, really very, very nice hearing from you a lot about this. And thank you for giving and sharing your knowledge with us. All right, thank you so much to all the speakers for their amazing knowledge sharing. For those who have been seeking for answers, I believe many of us out here, we want to look for answers. We are looking for answers. We want things to know, right? And I'm pretty sure that your knowledge has reached many people out there from many different backgrounds. And today we have many participants ranging from students, bankers, industries, and many more. So over here now we have finally come to the most important part of our event, the most awaiting moment for our participants, question and answer session. All right, now again, I would like to remind everyone, if you have any questions, you can ask the questions in the question and answer at the right-hand side bottom. And or if you would like to ask any question verbally, you can raise up your hand and you can ask, and the host will allow you to ask verbally. Now we have a questions over here. Now, since the question and answer can be viewed by all the participants, and I will actually read the questions to the participants, to the speakers over here. This is from Suja Premachandran. Hello, I would like to know in Malaysia if we are having a pilot program for developing smart city. Thank you. So, Mr. Osman.
Sure. When I was back in Malaysia, I remember there was a couple of projects ongoing at the time, especially the one which is from Cyberjaya. There is a CyberView company which was working on enabling some parking-based applications and some sensor-based applications. Secondly, Tenaga National was involved in rolling out smart meters. And I think they have done it at a couple of sites. So what I've seen is, again, there is a silo there. For example, Tenaga will be only focusing on the aspect of energy. CyberView, probably they are only interested in certain type of use case. So it is ongoing on that, on the direction. But probably city councils like DBKL or Cyberjaya City Council or Putrajaya City Council, they need to come in to basically work with partners, because this game is impossible to play without partners. To sum it up, it's basically the city council are the one who are going to say that, okay, we have these problems. So that, the electrical engineering company, can you help us with this? Software industry, software companies or AI companies, could you help us with these things? And then they can actually come up with a certain type of a solution.
Basically, you say close collaboration from all these departments is crucial for successfulness of these smart city projects.
All right, that's nice. Mr. Peter, what about you? Do you have any idea about this?
I know that there were a couple of very initial smart city proposals in both Malacca and Penang, but ever since I left MDEC, I've not really kept up to date with what they're doing. So I really don't have anything about the progress of smart cities.
I also want to add something interesting here, which is like when I work in Australia or Malaysia, a couple of other places. What I found out is one of the biggest challenges is the communication between different companies or organizations. So probably many companies, they want to just focus on doing their own stuff, but they don't want to come up and talk to other companies and other stakeholders, which is also one of the hurdles in enabling smart cities in different countries. I face the same problem here in Australia.
Oh, okay. All right. That's very nice. Thank you very much. We have another question over here that is by Mr. Hazminuddin Hussein. Now, he asked, in Malaysia, where can we hire good data scientists and data engineers?
Okay, I can answer that first. Yeah, half million data scientists and data engineers are actually everywhere in Malaysia. If you look at most of the GLCs, but they do have a team between 5 to 10 data scientists. So you can pretty much put up an advertisement, or you can actually look, get the recruitment agency to actually start looking for you. But the only advice is do hire carefully. Besides looking at their education and where they actually work, do look at the project experience. The project experience plays a lot of weightage in how good they are, and also it can also tell you how passionate they are, about data science.
What about you, Mr. Arshad? Do you have any idea about this?
Yeah, so there are, as Peter has just mentioned, that there are people actually going to this field. You can see a lot of job opportunities, and a lot of universities are offering these skills. Besides that, also there are online courses available for these data scientists and data engineering kind of disciplines, which people are in Malaysia are taking. Now, where we can hire good data, so that would be the online web portals, job portals, where people have put their websites, their resumes. That is the best resource to get to have the people's resumes. I think that is the best resource to get resources for these things. And again, this is evolving. This is an evolving thing right now, and it's not yet hit to maturity. So it's gonna improve the quality, the people with these right skills, and this is what actually basically you can consider one of the challenge for this field, big data. Short of skill resources, it's very hard to get good resources, people with the right skill set. And as you can distribute into data scientists, data analysts, and data engineers, there are three different kind of things. So this thing is evolving. People are still lacking on that thing, but good thing is that a lot of universities have started to offer this. And we can, for example, the businesses can directly approach those institutes and get the fresh graduates directly from there so that they're going to need some training. You cannot, it's because of the immaturity right now in this field, you cannot get a very kind of expert or experienced resources in this regard. So businesses have to do some compromise as well. Maybe get an experienced resource first, and also hook up with the junior resource, get them trained, and over the next few years, get them trained to come up with the excellent team to drive their business needs. So I think there will be some compromise need to be made by the businesses to get the best out of it.
I see. So what about if you have anything to say to the students over here?
Right. Okay. To improve themselves into this domain is basically start small, and even let's say if they are in a domain, or if they are in a university right now, or an institute which offering that, go get those courses, of course. And Google on internet, there are a lot of excellent classes, online classes available. If I name it, like Coursera, like the others, they offer excellent courses from different. Intel has a variety of courses available on Coursera. Google has its variety of courses available in this Coursera. Coursera basically is an online teaching kind of website. So start going for those courses. Some are free, some have some cost involved, but nominal, not that much. So start going with the initial kind of introductory courses, start build up their knowledge, and see from there on. Once they have the introductory knowledge, after some time they will know which domain, like they want to be a data scientist, they want to be a data engineer, or data analyst. So they will know from there. So start building their knowledge slowly, step by step. They have to go, they have to experience, they have to play around with the things that they've been taught in those courses. And from there on, not everybody it's like that. Means not everybody can be a data scientist, not everybody can be a data engineer, because they're kind of different domain, different kind of thing. So they need to go into that and see which one suits for them or them their kind of exactly.
Yeah. All right. So we have another question over here. Before we can have good data for analysis, how to improve the quality of our data?
I think for me, short answer would be there are quite a number of techniques basically on the deep learning or machine learning disciplines. They offer some techniques, but of course, this is the job of a data scientist. When they are doing a data engineering, they need to sit down and do analysis, see which data is important to and which data is redundant or not important, those kind of things. So this is very subjective. It's a subjective matter. Sometimes a data that seems valuable, but in the actual run or in actual decision making, that's not really worth it. So that's where a data scientist or data analyst need to make a call whether to include that data or not, whether it's quality data or not. And also, besides that, also this is one aspect of that thing. The other aspect is the data generation itself. How to that is also more like that will be a more engineering kind of domain where they need to make sure the data coming up, for example, from sensors or from other things is error free or all those things. There's another aspect of data quality. So there are two aspects. One is the data generation itself to be coming from reliable resources. The other is to select the data for decision making. Also, that's the job of a data scientist or data analyst, to not to use the noise in between for decision making. Otherwise, the quality gonna compromise of the decision quality will be compromised.
All right. Okay, that's nice. What about Mr. Usman and Peter?
So basically, from the IoT perspective, especially when I have explained earlier about deploying sensors, a lot of sensors when we deploy IoT sensors. And one of the key aspects is that the standardization of putting the actual format of incorporating the data itself. Secondly, I think one of the key aspects there is when you have those analog digital sensors connected to different type of use cases, parking bin pits, so on and so forth. You need to do proper calibration. It's a more engineering thing, but it is actually very important because we also found the same problem where, let's say you have a bin which need to basically being monitored for let's say 3 feet. So you have to make sure that it is properly, the sensor is properly connected at the right place, and it is really sending the data which is accurate. So from the source of IoT, source as an IoT, the key aspect there is that whatever the data that you generate from there, it needs to be properly calibrated and properly transmitted. Security, of course. I mean, without security, it doesn't work. And I mean, one example I could give is LiDAR. The LiDAR that we are using at the edge computer is generating 1 gigabyte of data per minute. And it is actually impossible to transmit 1 gigabyte of data per minute to the backend cloud system. So what we are doing there is basically we have developed one perception algorithm which perceives the overall scene and extract the relevant information, accurate information, and then send it back to the cloud that we have developed this framework with. So again, I think if you tackle it from the actual source, then the quality will be better, I would say, as compared to when it arrives on the time when data engineers need to work on it.
All right, that's nice. Mr. Peter, what about you?
Yeah. Okay. So besides installing sensors and all that to generate the data for clean data, right? I think to really improve the quality of data, you really have to automate as much as possible and also remove the human factor. Like for example, right? Let me give you an example, right? Yeah. If you are a retail or a bank or whatever, and you have a form that actually allows people to key in the date of birth. That is actually going to be very prone to mistakes, for example, right? So I mean, why not just have them slot in, using a device and slot in their ICs into this device, and this device is able to read their IC, right? So that is actually one good example, because if you know, right, data quality and data processing is actually part of the extract, transform, and load process or the ETL process. Right? And data can be dirty in a variety of ways. You need to harmonize the data. For example, I mean, imagine if you give a field to the users to actually key in the city that they live in, so some of them may key in a KL, some of them may actually key in Kuala Lumpur, some of them may actually key in K.L. So there are actually more than 50 ways for you to actually spell Kuala Lumpur. So to improve it, you need to be able to harmonize data. You also need to be able to deal with missing data. Sometimes IoT sensors, if there's a problem with the network, big data may be missing. And sometimes you also need to be able to deal with outliers. So, for example, if a person actually keys in his date of birth to be like 1750, so he's going to be probably over 250. So that's obviously not. So you need to be able to deal with this kind of thing. You're muted, Sharon.
Oh, thank you. I'm so sorry. All right, so we have another question over here from Mr. Saparin Nasir. Now, he has asked, how about the infrastructure in Malaysia? Are we ready for it? If not, what is the plan or the milestone for it?
What I understand about the infrastructure from digital infrastructure point of view, you know that the 4G coverage is quite good in overall Malaysia, and the wireless basically telco coverage is quite good. But whereas when we talk about the IoT sensors and actuators, they actually need a different set of wireless technologies. As an example, they have very certain needs, such as the bin sensor, parking sensor, especially the parking sensor when it's going to be part of the road. They need to actually run for 2 to 3 years on a battery. So they use a low power wide area network technology such as LoRaWAN and so on and so forth. So I have come across that there were a couple of pilots going on as an example, in Cyberjaya, they were using LoRaWAN, and Intel was also involved. That's how I also get to know about it. So again, from pilot point of view, the infrastructure, I think people are doing it, but from the back end point of view, so there's a front end and there's a back end. Front end means in this context, you have IoT devices connected to the gateway. And then you have a gateway or edge devices connected to the backend system or a cloud system. So I would say that there is a wireless infrastructure is only providing the backend infrastructure, whereas in the front-end infrastructure, I think it depends on, again, whenever they are going to deploy the use cases.
Okay, Mr. Peter, what do you think from your point of view? Are we ready?
Yeah, so I'm not really sure what kind of infrastructure that Saparin is talking about, but if you're talking about infrastructure to perform big data analytics or even artificial intelligence, but yeah, I mean we have a pretty decent broadband speed in Malaysia, right? And we have at least five cloud platform providers, that are operating in Malaysia. Right? You've got your Amazon Web Service, you've got your Google Cloud Computing Platform, you've got your Microsoft Azure, you've got AliCloud, you've got Huawei, right? And these cloud computing platforms are your what we call as your software as a service, or the infrastructure as a service provider. It allows you to, for example, set up like 100 to 500 or even 1,000 virtual machines with actually very minimum cost. Okay, it allows you to actually load your data over there, perform artificial intelligence, get the results, and you decommission on your virtual machine. Okay. And it's probably going to cost you, a few $1,000s. Okay. Now compare this with having to actually purchase your own on-premise machines. That would easily cost you a few $1 million. Okay. So yes, we do have the infrastructure in Malaysia, and if you want to perform any big data analytics, even artificial intelligence, and if you have the data, there is absolutely no excuse not to do it in Malaysia anymore.
If I add something on top of it, I can thank you very much, Peter, for explaining very well. I think from the university point of view, there are two things that university can do. The first one is the university can actually get the research or academic accounts with all the 5 cloud providers. We did the same thing with AWS and Microsoft in Malaysia University initially. So they can give you, let's say, $10,000 of credit, and you can actually use it for building your innovative research and development applications. Second one is there is a plethora of open source software. So if you want to create your digital infrastructure, you can actually refer to different type of GitHub available open source, and you can build your own digital infrastructure in your university, which can provide a baseline for future application towards big data analytics for industrial revolution, smart cities, and so on and so forth. So I think the key aspect there is to build test beds, tangible, workable test bed where students can see and experience how to actually learn from it.
All right. Okay. All right. So we have one last final question over here, right? So it is, what are the challenges of data-driven organization in fourth industrial revolution?
Can I answer that first?
Yeah.
Yeah. So like I'm just going to recap what I just presented. Right, the challenges of data-driven organizations in the fourth industrial revolution is, I think number one, I mean, at least in Malaysia, right? Number one, we really lack the talent. I think, right? We lack the expertise in advanced data processing, or text processing, image processing, video processing. So there are not too many. Given the size, there are not too many people with this kind of advanced analytic skills. Number two is, obviously a lot of companies, they do not really allocate proper budget for building a proof of concept or even use cases, because there is a perceived high cost of doing data analytics. Now, many people think that big data analytics is expensive, but that's because they really did not do their homework, trying to figure out the ROI for the specific use cases or use cases. And pertaining to that, I go to point number 3, which is the lack of business strategy. A lot of companies, they do not have data. And when they try to embark big data analytics, it's actually quite messy. So there's no direction, there's no clear leadership. A lot of people in management really do not appreciate the value of it. Back to you, Sharon.
Oh, that's interesting. Mr. Arshad, do you want to add anything after Mr. Peter over here?
I think Mr. Peter has summed it very well. I do also see the talent shortage is one of the biggest challenge that industry will face. Here I will add something more to that as well. That when we talk about the infrastructure, there was a question about the infrastructure. So there are two aspects. One is the physical aspect of the infrastructure, like the 5G, like the connectivity, and the industry itself, the edge. Compute power, the sensors, all those things. This pandemic has definitely slowed it down because of the companies are now trying to recover, trying to just to sustain, and this sensor enabling, all those things going to add additional costs. So this is going to slow down. So this is one of the challenge that industry will face in Malaysia to cope up. Not only Malaysia, all over the world. The second part is the talent shortage. When this thing in the next few years, then all this infrastructure is in place from the physical aspect. There will be an enormous gap over there for the talent, for the engineers, data engineers, data scientists, to fill that gap, to fulfill industry needs. And that's where I think the government what they can do is push university to add more and more, encourage the university to add more and more courses around, or more kind of a knowledge gain to the students, so that they, in next 2 to 3 years, they will be ready to fulfill industry needs. So this is one thing. That the other, I think this is more not very relevant at the moment. The other challenge I do see that the data right now, the data is coming from different resources, different sources. In that case, as Mr. Osman earlier said, standardization is needed, right? Because of that, not having a standardizing, how to manage all the data from different sources with different kind of formats, all those things, and that enormous data, that will be the biggest challenge the industry 4.0 will be facing in next few years until everything gets standardized. So just back to you. Yeah, this is 2 things I can see.
All right. Okay. Thank you very much. All right. So we have come, now we have ended all the questions, and looks like we have answered all the questions asked by the participants. And great. Thank you. Thank you for the speakers, Mr. Osman, Mr. Arshad, and Mr. Peter, for spending your time with all of us today, giving your vast knowledge, giving your experiences from a different background. And I hope that this webinar today, it has benefited a lot of people out here. And thank you very much. We hope to see you again next time. Thank you very much.
Thank you, guys.
Thank you so much.
Thank you very much.
Thank you.